In this video, we're going to go over how to send data from an SD card over MQTT using Arduino. This is an example sketch for the B data logger, which is a fully featured ESP32 data logger board. You can find out more about that board in the link below, but even if you don't own that board, you may still find bits of this code useful or informative. And there will be a link in the description down below to this actual code file so you can poke around at it if you want. In any case, let's get started. Now, the genesis for this sketch is being able to send data that you have on an SD card over MQTT. So if you want to send it to a server or whatever use case you may have, this is how this works. Now, for this particular board, the B data logger, like I mentioned, is an ESP32 data logger. It has a special feature where it can detect if you have USB power or not plugged into the USB port on the board itself. And so what this code is doing is, for an example, if you were just logging data and you were sending it over MQTT and you had it plugged into USB power, whether, in a wall outlet or connected to your computer or whatever, it would just continue sending MQTT messages. But if you lost that power, like your computer shut off or you lost power to your house or whatever the case may be, then as long as you have a LiPo plugged into it, it will automatically start saving data to the SD card that's has an SD card reader on the board. And then once it detects the USB power has come back, so your computer's been turned back on or your power to your house comes back, then it will dump the data that it saved to the SD card when it didn't have power over MQTT. The idea being is if you're trying to log data over a long period of time, you won't have any gaps in data if you lose power to your house or whatever. So you can save data to the SD card and then dump it. So that's basically what the sketch is doing. But I'll go over the more kind of complicated bits in detail on this video, just so you have an idea. I did go through and comment as much of this as I could, and hopefully make it somewhat understandable, but sometimes actually explaining it makes a little more sense sometimes. In any case, we're using a few different libraries. We use the RTC lib, we use an ESP32 MTC client. They're open source. And the B data logger has a built-in real-time clock, and it has a built-in SD card slot. So we're leveraging both of those things on this particular board. But if you're using some setup where you don't have, either of those things, or you have an external SD card and you're kind of wiring it in yourself, you can probably still use some of this code. In any case, we have a sleep timer here, so when we do lose USB power, we don't necessarily just want to leave the board on continuously when it's running on LiPo power, because we don't know how long the power is going to be out for necessarily. So in this instance, just for testing, I have it go to sleep for 10 seconds, then it wakes up, checks to see if there's USB power. If there's not, then it saves the data that it reads from whatever sensors are connected to the SD card, goes back to sleep for 10 seconds and repeats over and over again until there's USB detection or USB power detection again. Okay. We have our MQTT client we set up, so you'll need your Wi-Fi name, your Wi-Fi password, the MQTT broker IP. If your broker has a username and password that you need, you can put those here. If you don't need this, you can just delete these two lines, and then you can name your client. So whatever this board is that you're putting this code on, this is what you'll name it. And then obviously the port for your MQTT. Some of this I'm just going to skim over because it's not necessarily relevant to the actual topic of this video, but I'll just kind of briefly explain some things. This is for our real-time clock that's built into the B data logger. We can pull out the exact day that something, so if you collect data on a Monday, we can say, hey, today's Monday, and not just the date necessarily. We have some variables. We can wake up the B data logger with two different sources in this instance. One, is from the timer, and then we can also wake it up when USB power has been restored. Okay, so we basically just print, hey, what woke up this board? These are some ESP32 SD libraries. These come if you install the ESP32 board libraries. They have these default libraries built in, and this is one of them. This is for the SD card. So this is just initializes the SD card. These are just functions that we will call. So we don't actually have to do anything in any of these for the most part. Write file, append file. The only one that I've modified is this read file. And this is where it's doing the actual reading of the SD card and sending the data over MQTT, okay? I'm going to try and explain this as best I can. And so how we're saving the data to our SD card is basically one line across is one entry. And for each piece of data, it's separated by a comma. And I'm going to bring over this. So this is kind of what your data entries will look like. So for this code or example, it's saving the date, it's saving the day, it's saving the time, and it's saving a temperature reading. Now the temperature reading is from the RTC. Built-in RTC has its own temperature sensor. It's not very accurate. It's just kind of there for temperature compensation to a certain degree. But you can pull that data out. So I just set it up as an example so you have some sort of actual data to look at. But if you want to do like precise temperature readings, you would want to use an external temperature sensor. But anyways, this is how these different data entries look. So this is an entry, this is an entry, and each piece of data is separated by a comma. Okay, so that's how we're doing this. And so what it does is we open the file that's on the board or on the SD card, and we file and we read a string until there's a comma. So for each bit of data, we're going to read until we find a comma. So it's going to read, this data entry, comma. In fact, let me zoom in here. It might be a little bit easier to see. So we read this bit of data until we hit a comma. Then we read this bit of data until we hit a comma, and so forth, okay? Now, so we're going to go comma and comma. We're putting this into a buffer. So what it's going to do is we're going to read to the first comma, and then we're going to save that data here, okay? So I know it's a date because that's how I set up my data entries, but however you are saving your data to your SD card or whatever format as far as what data entries go where, you can name these however you want. I'm going to save it as a string. And I just did some print lines for some debugging, but this is where it actually prints that data to MQTT. And this is our topic that we're subscribed to, basically, and sending data to. So it's going to go to a comma. It's going to do this one. And it's going to reach to the next comma, save the next bit of data here. Okay. Next bit of data here. Next bit of data here. So this is the last piece of data in an entry. So it's this one. Now, there's no comma at the end of this, so we need to tell it, where to stop. Otherwise, it'll go down to the next line, and your data will get all jumbled up. So what we do is we read until a carriage return character. I will explain that a little bit farther down when I'm showing you how I'm saving this data to the SD card itself. But this is how we do it. We look for carriage return. And once it's done that, it's gone through an entire entry. It gets down here. And since this is a while loop, if the file's still available, well, we haven't finished reading all the data. So one loop will read all this, and it'll get to the end, and it'll be like, while it's a while loop, it's like, hey, is this file still open? Yes, it is. Okay, well, we're going to the next line. And then it'll repeat that over and over again until it goes through every single line. And that is how it will send that data over MQTT. Now, I will show you this working a little bit, but I'm going to finish going through the rest of this code real quick. So for each piece of data that you have, you'll need basically kind of a block that looks like this. Okay? You can get rid of the serial prints if you don't want to have any sort of debugging, like you don't care about that. But I put it in here to make it easier to kind of understand, hopefully. So that's how you read from the SD card and send it over MQTT, okay? We have on our connection established, this is an MQTT function where as soon as it connects over Wi-Fi and it connects to your MQTT broker, it'll basically, publish, basically connect. It will initialize the SD card, and then we'll read from the SD card the file that we have as a backup. And if there's no file there, then it'll be like, okay, there's nothing here, and it'll just continue on, and then it'll just send us MQTT messages. If there is a data on the backup.txt, then it will dump that data as I just explained, okay? We have a function for deleting files, and now we have the send MQTT function as well. Again, we have some variables that we've made. So we have our temp from the RTC temperature reading, which again, like I said, is not very accurate, but it's just something to look at, I suppose. We put most of these things into strings, okay? And then we do just a client publish, and we do it to whatever topic you're wanting to send it to, and then obviously your variables of each different thing, okay? As far as like, this is for the RTC, if you wanted to change the format of the date, you can move these around. So if you don't want the year first, the month second, the day last, you can flip them around or whatever, however you want it, okay? And this will basically just publish this data, and then the client loop just loops through it, and it'll just keep going indefinitely, basically. This is the backup to the SD card function. The B data logger has an RGB LED on it, so I just set it to blue for debugging, basically, so it'll turn on when it's writing to the SD card and turn off when it's in sleep. You can comment this out if you don't want it. We save our temperature, basically do all this stuff again. We're going to initialize the SD card. For the very first time, it's going to try and open backup.txt. If it's not there, if it doesn't exist, then it'll create it the first time. Okay, that's pretty self-explanatory. And then down here is where we actually save the data to the SD card. Everything needs to be in a string, because that's how we're saving it to our SD card, okay? And our data message is the entire entry. It's this right here. So data message is this entire thing. Move this out of the way. And so we got a string, and then we add our months, our day, and our year. And let me bring this back over here. Maybe this will. So that's this bit right here. Our day of the week right here. If I highlight it, it's going to go behind. This right here is that. Then our time is here. And then our temp at the end. And you can see how each thing is separated by a comma. Okay. And then lastly, at the very end, we need our carriage return. This is, trying to get this in frame. Hopefully, let's see. There we go. Sorry about that. This is our carriage return, and this is what we're looking for when I showed earlier up at the end of a entry. And then we also put a new line in there as well. But you need this for this to work, okay? Your carriage return. Then we save it to the data, and then we append the file to backup.txt, and we attach that data message as a string. That's how it backs up to the SD card. From there, it's basically pretty straightforward as far as you have your normal setup and your normal loop. I enable the bDataLogger helper libraries. If you're using a different board and you're using bits of this code, you don't need these particular things. We print the wake up reason. Did it wake up from the timer, or did it wake up from USB power? This is just kind of a debugging thing. You don't need that necessarily, but we start the RTC. And if the RTC has lost power at any point, then we can reset the time. If you're using the little coin cell battery backup, this should always keep its time, so that this will never run, basically. So in our void setup, though, we're going to get down here, and on the bDataLogger, like I said, we can detect if there's USB power. So when it boots up, we go, hey, we check to see if there's power at the USB. And right here also we set the USB as a wake up source. So if there's power to the USB, we set that as we wake it up. But in any case, back to the detection. If the USB is false, so there's no power to the USB, we initialize the backup SD card function, which saves our data to the SD card. And we set a timer to wake up at that 10-second interval like we showed at the top, which you can change. And then we go to sleep. Sleeps for that amount of time, wakes up, comes back in, checks it, see if there's USB power again. If there's not, or if there's no power, then it does this again. It just loops that way. If there is USB power, obviously we don't get into this, and we just come down here to our loop. And again, we check it. And we want to be doing this continuously because this is a loop function, so it's just going to keep running over and over again. And so we want to be able to tell at any point if we've lost power. So if there is power, we're just going to send our MQTT messages like normal, just loop them over and over and over again. And if it's false at any point, we back up to the SD card, we set our wake up source as a timer, and we go to sleep. And that is basically it. Now, with that running, I'm going to show you how this works, okay? So I've just got these basic messages here saying, hey, QTT has been sent. I'm going to pull this up. And right now it's sending these 4 data points. It's setting our day, it's setting our time, and it's setting our temp. Now, temp is not accurate. Like I said, this is the built-in real-time clock one, and I've been handling this board around, so my hand's been increasing the temperature as well, so that's not super accurate. I wouldn't pay attention to that. But as a data point, that's what it is. And then we have our date. So we have the day, or sorry, the year, the month, and the day. And again, you can change these around however you like. Okay, so what I'm going to do is I'm going to unplug this board from the USB, and it's going to go into sleep mode. And I'm going to let this run for about a minute, and then I'll show you what happens when we plug it back in and it dumps that data off, okay? So just bear with for a second. I'm going to pause the recording, and then I'll come back. Okay, it's been running for about a minute or two, so we should have a number of entries saved to the SD card. Now, I'm going to plug this back in, and when I do, if you pay attention over here in the serial monitor, it's going to spit out a bunch of blocks of all that code. And it's going to do this very, very quickly. And at the same time, over here in our MQT Explorer, we'll see it update. And I've also got a Node-RED instance going where it'll show debugging messages so that we can actually, so I can actually show that they are, in fact, actually being sent over MQTT, because it does happen very quickly. On the Node-RED, I just have the temperature turned on, so it's a little bit easier to see, but all that data is coming through. So I'm going to plug it back in and give it a second. So that's sent, it's connected, boom, and there they all go. So these are all of the messages that were sent from the SD card, okay? And they come through very, very quickly. And then after it's done that, it'll just continue on sending its normal updates. Let me drop down here. And let me show this again right here. So these are what all these different little blocks look like. Pretty straightforward. These are all the ones that I pulled off the SD card. Very cool. So anyways, that is basically how that works. Hopefully you found that informative and useful. If you are interested in the B data logger, it is a very feature-packed ESP32 data logger board. Links are in the description below. It's open source. I have a whole bunch of information on the GitHub about it and where you can purchase it. And if you don't have that and you're just trying to figure out how to send, you know, SD card or messages off an SD card over MQTT for some reason, hopefully this code has been helpful for you to figure that out for whatever project you're working on. So if you like this video, please like and subscribe, and I will see you guys in the next video. Thank you for watching. Bye.